Hello students, welcome to Sri Vardhaman Vidyalaya online education. Today we will see the part 3 of chapter 12 electricity. In this chapter we are going to study about the factor affecting the resistance of a conductor. The electric resistance of a conductor depends on the following factors. First, the length of the conductor. Second, the area of cross section of the conductor. Third, the nature of the material of the conductor. Fourth, the temperature of the conductor. So first, the length of the conductor. The resistance of a conductor R is directly proportional to its length. So R is directly proportional to L. The resistance of a conductor is directly proportional to its length, that is, when the length of the wire is increased, then the resistance also gets increased. If the length of the wire is decreased, then the resistance also gets decreased. Second, the area of a cross section of the conductor. The resistance of a conductor R is inversely proportional to its area of a cross section. So cross section is denoted by the letter A. So R is inversely proportional to A. The resistance of a wire is inversely proportional to its area of a cross section. That is, when the area of a cross section is increased, then the resistance gets decreased. When the area of a cross section is decreased, the resistance gets increased. Nature of the material of the conductor. The resistance of a conductor depends on the nature of the materials of which it is made. Some materials have low resistance where others have high resistance. Temperature of the conductor. The resistance of all pure metal increased on rising the temperature and decreasing on lowering the temperature. The resistance of alloys like manganese, nichrome is mostly unaffected by the temperature. So these are the alloys like manganese and nichromes are not affected by the temperature. Next we are going to see about resistivity. It has been found by experiment that the resistance of a given conductor is directly proportional to its length. So that is R is directly proportional to L. The resistance of a given conductor is inversely proportional to its area of a cross section. So R is inversely proportional to area of a cross section. By combining equation and 1 and 2, we get the resistance is directly proportional to the length and inversely proportional to the area of a cross section. To remove the directly proportional proportionality, we put in a constant. That constants we are calling as a rho. So here the equations will be changed as R is equal to rho into length upon A. So rho is a constant known as resistivity of the material of the conductor. So this is the formula for finding out the resistance. So resistance R is equal to rho into length upon A, where this rho is an resistivity, L is the length of the wire, and area A is an area of a cross section. So it is also known as a specific resistance. Now we can change this equation and we can write rho is equal to R into A upon L. The unit of the resistance is O. The unit of area of a cross section is meter square. The unit of the length L is the meter. So the unit of an resistivity rho is equal to, that is an rho is equal to R into A upon L. So unit of an R is an O, area is an meter square and length is an meter. So when we put this one, what happens here, the meter and meter square will be cancelled, so you will get an ohm meter. So this is a symbol for ohm that we are calling as an omega. So SI unit of an resistivity is an ohm meter, which is written as a symbol as an omega m. The resistivity of the substance does not depend on its length or thickness. It depends on the nature of the substance and temperature. Good conductor of electricity should have a low resistivity, and poor conductor of an electricity will have a high resistivity. The metal and alloy have very low resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. The insulator like rubber, glass have a resistivity of the order of 10 to the power 12 ohm meter to 10 to the power 17 ohm meter. So here the good conductor have low resistivity. So the alloys and metals are the good conductor. So they have a low resistivity in the range of 10 to the power minus 8 to 10 to the power minus 6 ohm meter. Where the poor conductor, that is an insulator like rubber and glass, they have a high resistivity. So that it will be in the order of 10 to the power 12 ohm meter to 10 to the power 17 ohm meter. The resistivity of an alloy is generally higher than that of its constituent metal. The alloy do not oxidize readily at high temperature. For this reason, they are commonly used in the electrical heating device like electric iron, toaster, etc. Tungsten is used almost for the filament of electric bulb, whereas copper, aluminium used for electric transmission line. Here the resistivity of alloy is higher than that of its constituent metal. You know that is alloy is made up of two or more metal. Then so the alloy will have a more resistivity than that of their original metal. So the alloy do not oxidize at very high temperature. So for these reasons they will be used in some heating electrical appliance like electric iron, toaster, etc. Tungsten is used for the filament of electric bulb. In a bulb you will have some filament. So that filament is made for up of a tungsten. Next, the resistance of a system of resistor. The current through a conductor depends upon its resistance and the potential difference across its end. In the various electrical gadgets, we often use resistor in various combinations. So the resistance can be combined in two ways, in series, in parallel. If we want to increase the total resistance, then the individual resistance are connected in the series. If you want to decrease the total resistance, then the individual resistance are connected in parallel. First we will see series. When two or more resistance are connected end to end consecutively, they are said to be connected in series. Now see this diagram. Here this is take it as a resistance. So this resistance are connected end to end. This end to this end, this end to end. So this will be in a series form. Parallel, when two or more resistance are connected between same 2 points, then they are said to be connected in parallel. So this is in parallel. They will be connected in a same point. So this and this are connected in the same between 2 points. This point and this point. So here also for this resistance the point is this one. Here also this. So this 1, 2, 3 resistance are connected in the parallel. So this is the diagram for the series circuit and this is the diagram for the parallel circuit. First we are going to see the resistor in series. When two or more resistors are connected end to end to each other, then they are said to be connected in series. So here we are going to see the derivation for the series. So this is very important question. An applied potential V produces a current I in the resistor R1, R2, R3, causing a potential drop V1, V2, V3 respectively through each resistor. So total potential V is equal to V1 plus V2 plus V3. Here, look at this diagram. So here this is R1, R2, R3. They will be connected in the series, and this will be connected with a voltage potential difference. Now this whole circuit will be connected to the battery and key and ammeter. Now in this one, the potential difference across on a resistors R1 is V1, R2 is V2, R3 is V3, and the current will be passes through this one is an same, that is I. So the whole thing, the current is passing as an I. So by Ohm's law, V is equal to IR. So V1 is equal to I into R1, V2 is equal to I into R2, and V3 is equal to I into R3. Now substitute in this one, V is equal to V1 plus V2 plus V3. So in this one, V1 is what? I into R1, V2 is I into R2, V3 is I into R3. Now in this one, whole thing, I is a common. So take the common outside. So I is equal to, V is equal to I into R1 plus R2 plus R3. Now you know V is equal to what? IR. So IR is equal to I into R1 plus R2 plus R3. So in this one, I is a common, so it will be removed. So R is equal to R1 plus R2 plus R3. The combining resistance connected in series is equal to the sum of the individual resistance. So this combining resistance in series will be equal to the sum of the individual resistance. That is, individual resistance is what? R1, R2 and R3. Important points related to this series. The equivalent resistance is equal to the sum of the individual resistance. The equivalent resistance is greater than the resistance of each resistor. This is also known as an maximum effective resistant. The current through each resistor is same. The potential difference across each resistor is different. So here you can see that is a current is same for each resistor, and the potential difference for each resistor is different. So that is given in this point. That is, the current through each resistor is same, and the potential difference across each resistor is different. Disadvantage of a series combination. In series combination, if any of the component fails to work, then the circuit will break and none of the components will work. Listen, in the series, if this is not working, what happens? The current will not be flow, and what happens? The whole circuit will not be work. So in this is a disadvantage for a series. That is, if any one of the component fails to work, then the circuit will break and none of the component will work. It is not possible to connect a bulb and heater in the series because they need a different value of current to operate properly. In series circuit, the appliance do not get the same voltage as that of the power supply line. In the series circuit, all the electrical appliances have only one switch, due to which they cannot turn on or off separately. Resistor in parallel. Where two or more resistors are connected simultaneously between 2 points to each other, then they are said to be connected in parallel combination. So this is a diagram for a parallel combination. So in this one, you can see R1, R2 and R3 are connected in a parallel, and this will be connected to the voltage. So in this one, you can see that is current flowing is in a different. For R1 is I1, R2 is I2, for R3 is I3. So here the potential difference is same. So you can see that an applied potential difference we produce current I1 in R1, I2 in R2 and I3 in R3. The total current I is equal to I1 plus I2 plus I3. But in series you can see that total voltage, because the potential difference is different and here the current is different. So by Ohm's law, I1 is equal to V upon R1, I2 is equal to V upon R2, I3 is equal to V upon R3. If R is the effective resistance, then I is equal to V upon R. So put this in the equation, I is equal to I1 plus I2 plus I3. So V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. So in this one the V is common, so we can take V outside. So V is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So here this V and this V will be common. So this will be what happens, cut. So it will become 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the equation for resistor in parallel. So the reciprocal of equivalent resistance is equal to the sum of the reciprocal of individual resistant. Important points related to parallel resistance. The reciprocal of equivalent resistance is equal to the sum of the reciprocal of individual resistant. The equivalent resistance is less than the resistance of either resistor. This is known as minimum effective resistant. Here, the current from the sources is greater than the current through either resistant, and the potential difference across each resistor is same and the current is different. So you can see this one. The potential difference is same. So V is common for all and current will be different. So I1, I2 and I3. So this is that the current from the sources. So when we are getting a current, so we are getting the current from the sources. So I is greater than I1, I2 and I3. So this is the meaning of this sentence. The current from the sources is greater than the current through through either resistor. Applications of parallel combinations in daily life. The parallel combination of resistant is highly useful in circuit used in daily life, as the circuit used have component of different resistance requiring different amount of current. This type of combinations in a circuit divides the current among the component so that they can have necessary amount of current to operate properly. So this is the reason of connecting electric appliance in parallel combination in household circuit. So you can see that in a house, those connections are in a parallel. But if it is in a different room, so in particular one room, the connection is in a series, but the whole house, the connections will be in a parallel. So if you have any fault in a room circuit, what happens? The room lights will be switched off, not the other rooms, because of a parallel connections. Why? Because in parallel connections what happens, so it will not be either, if it is a one fault is there, they will not affect, but in a series connections, if the one appliance is in a fault, what happens? The whole series will be break. So this is the advantage between the series as well as a parallel combinations. Hope you have understood. Thank you. We will see in the next session.